Okay, I think we can start terus lah kot. Sorry, I terlambat sikit sebab I replying to the message dengan call tadi. Alright, sekejap. Okay. Okay. Chapter 5. Okay. Alright, boleh nampak eh? Okay, sorry, I takut I tak boleh baca your message. Boleh nampak eh?
Boleh.
Alright, okay, thank you. Okay, so continuation daripada tadi. Okay, tadi kita go lattice ataupun sorry, truss ataupun lattice girder. Okay, now we are going to space structure system. Okay, macam saya cakap tadi, space structure system is a continuation daripada truss. Truss is a 2D. Okay, space structure. Bila kita susun trusses banyak-banyak, align and then interconnected, it becomes this space structure ataupun in architecture we usually refer them as space frame. Okay, space frame ni biasanya you akan guna for a long span buildings. Okay, in your project perhaps mungkin you guys pernah guna sikit during your 05 punya project kalau ada long span punya area, especially multi-purpose hall ataupun auditorium. But I usually see space frame is used in your design 08. InsyaAllah next semester lah you'll be in 08 kan. So in some ways you will get familiarized in space structure, space frame structure if you opted to use this kind of aesthetic ataupun long span punya spaces. Okay, but depends, ada juga yang 08 pakai timber, ada 08 pakai concrete. So up to your design ataupun your intention in your design. Okay, alright. Okay, for this lecture, trusses are defined as structural system in which the members are interlinked so that they are only subject to axial compression or tensile forces. Okay, this definition assumes that no action is applied directly into the members. All loads are applied to the joints, which are known as nodes. Okay, tadi I dah cakap few times juga. Okay, in case it is impossible to guarantee the coincidence of member axis, the bending effect resulting from this must be evaluated. Sorry, I lupa. Apa nama Ridwan, kalau anytime you boleh start record kalau terlupa tadi. Okay, it is particularly important to ensure that the axes of the members coincide. Okay, only perfect pins can completely ensure compliance with this loading condition. Okay, alright, macam ni you tengok dalam diagram ni. Okay, this is where the center lines of each of the axis of the members intersect. Okay, perfectly. Okay, it forms nodes. Satu nodes je. Okay, but this one, center lines do not intersect because dia punya member is not connected directly. It's not connected by the perfect joint or perfect angle. Okay, so dekat sini, on the jointing itself, dia ada three different nodes. So that's where the calculation on the nodes become complicated and it's not easily determined. Okay, so this one on the structural integrity ataupun strength, it is more secured ataupun is more sound atau how do I say? It is more workable and is more practical on the left rather than this one. Okay, this one, there are the chances of failures because when you have different nodes, you have to remember different nodes are the different points of loading. They might be not carrying the same loads. But this one, when you have one single nodes, it carries the exact same of the loads and it is evenly distributed rather than this one. We do not know which nodes carries most of the weights or carrying less weights. So there are chances that this structure would fail or deform. Okay. So the technological construction of the assemblies deviates to some extent from this theoretical situation, and in fact, is one of the main difficulty associated with this structural system. Okay, so only perfect pins can ensure compliance with the loading condition. Alright. Okay, macam ni, kita tak tahu dia punya loading condition macam mana. Okay, alright. Okay. Okay, the lecture is concerned mainly on the truss system for roof, which span in two direction. Okay, term space structure. Susah sikit untuk I tunjuk sebab online, but perhaps ada some of the diagram tadi I can relate lah. But otherwise I can draw. Okay, tapi I need you to imagine lah in some ways. Okay, alright. Okay, which span in two direction. Okay, contoh one direction is this one. Okay, this is one kita nampak daripada 2D. Okay, tapi bila kita pandang daripada kiri ataupun kanan, they have another one. Okay, dia akan join dekat this one, tapi dia akan ada another one yang macam ni. Alright. So, bila kita ada development daripada truss which is planar 2D, and then ada another one that aligns together, it creates three-dimensional. And within this three-dimensional punya spaces, it's where we call it by space structure. Okay, and other arrangement as possible as such continuous system based on the Verendel girder. Verendel ni is the one of the founders that come up with this structure. Okay, all right. Based on the Verendel girder, in which diagonal bracing members are unnecessary because the bending behavior is predominant rather than the actual one. Okay, the resultant voids can be used to accommodate mechanical and electrical services. Okay, boleh you tengok dekat ni. Okay, the diagonal members is not significant ataupun can be ignored, unnecessary. Okay, because the structure of the verandal girder itself is strong enough to resist the axial load from down and up. Okay, this is the point loading and where the loading subjected from up. Okay, all right. So it doesn't need any kind of bracing. Okay, all right. Okay, historical background. Okay, until the 1960s, almost all trusses systems are two-dimensional. Okay, yang ni lah, very basic. Okay, they have developed from timber roof, which themselves had evolved from basic triangular arrangement to more complex shape. Okay, which is in figure 3. 3A has led to introduction of the suspended. Okay, this one, it's to distribute the load. Again, when we are talking about structure, we are talking about how we can distribute the structure effectively. This one, bila dia ada connection between the ridge of the roof, okay, dekat atas ni, and the suspended that tie back to the beam, okay, it carries some loads that supposedly being carried by the tie beam. It suspend back to upwards towards the ridge, and then dia akan redistribute to the sides of the roof. Okay, right? So that's why they can um, achieve the equilibrium of the forces ataupun the distribution of the loads tadi. Okay, that's B. Okay, another one is a tie. Okay, they have more members, so that's where the loads can be more evenly distributed. All right. Okay, this one. Okay, on the last one, D, did that eliminate the tie beam? Okay, another use of the tie beam is to carry the load, but at the same time retains the shape of the roof. Okay, but this one, when they have some ties and make up of the suspender and the tie, okay, the overall ataupun the bottom chords of the beam tadi can be eliminated. Okay, how ataupun why? Because to eliminate the overall width of the roof. Okay, supaya dia tak berat, supaya dia ringan. Okay. Okay, the use of the metal become dominant in the 19th century for all types of structure except domestic buildings. Okay, metal is considered a high-tech ataupun advanced building material in 19th century. So that's why the use of the material the use of the metal are more limited to the large span structure ataupun bigger structure rather than domestic macam rumah ataupun residential ataupun offices jarang-jarang guna metal. Okay, this is for the infrastructure ataupun mega structure that the country or the government develop. Okay, alright. Articulated system commonly used for roof are the railway system are perfect examples of the two-dimensional triangulated system. Okay, so there are a lot of examples, and railway station really exhibit some of the two-dimensional triangulated system that use for the space frame. Okay, the second half of the 19th century was characterized by some of the remarkable achievement. For example, Garabit Viaduct in France, which is pictured in Figure 5, and the Maria Pia Bridge in Oporto. Okay, ini tak ada gambar. Okay, designed by the Eiffel. Okay, Eiffel pun um, macam Eiffel Tower, develop the Eiffel Tower tadi, dia are using the metal. So the advancement of the technology allows some of use of the metal and the technology of ataupun the development of the space thrust, because the entire construction of the Eiffel Tower also we can see it is made from space frame ataupun space truss. Okay, alright. Although the spatial system were proposed early in the 20th century, their use in practice has arisen from the more recent development of computer methods for analysis, the functional needs for spaces free of columns and demands of the architectural appearance. Okay, macam kita, as architects, we try to eliminate the use of the columns as much as possible. Okay, so that's why there are a lot of ways or architectural um, fits that we can try to incorporate in our design so that we can have lesser amount of column placement ataupun apa nama tadi, support. Okay, so support still ada tapi we can eliminate the use of the column. Okay, so that's why the use of the arch ataupun the large span structure is very important. Okay, especially for spaces yang kita design for accommodating a lot of crowds ataupun tourists. For example, multi-purpose hall, auditorium, okay, mosque, okay, especially macam masjid kan. Kita ada staff, so we as designers, we try to eliminate as much as column as possible supaya staff kita punya staff tu tak putus. Okay, otherwise dia akan macam pelik sikit lah. Ataupun kalau you perasan dekat surau-surau macam kecil kan, uh, kadang-kadang the space is wasted because that's where they place the column is. Okay, right? Okay, different types of system. Okay, introduction. Okay, different types of the spatial truss system are normally classified according to their general shape. Okay, there are three shapes that are typically being used in spatial truss system, which is two-dimensional grids, cylindrical vaults, and domes. Okay, nanti kita akan go through one by one. In each case, it is advisable to distinguish between the single and double or even triple layer grids. The number of layers depending on the span. Okay, a third characteristic lies in the geometry chosen for the system of the member in the layers and possibly in the composition of the bracing of the layers. Okay, for this space stress system, there are the single layer, there are the double layer, and it can go even triple layer grids. Okay, this is a form of grids. Okay, bila kita cakap pasal space truss, it is arranged together. So ada some grid punya discipline ataupun arrangement. Okay, and different layering. Okay, for example, single layer, double layer, dia ada different number of span. Okay, for example, single span, maybe dia only can cater for shorter length or shorter span. Double, it can not necessarily by doubling the number, but it can increase significantly the span or the length of the uh, between the support and another support. Okay, nanti kita akan go tengok by visual. Okay, and also the characteristic of the geometry chosen in the system. Okay, Bila kita ada space truss, kita have a lot of modules. It made up of the smaller modules of different shape. It could be triangulated, it could be square base, it could be pyramidal space. Okay, nanti kita akan tengok few examples. Okay, so different shapes ni ada different characteristic in terms of dia punya strength in the structure. Okay, single layer grids. Okay, these grids are mentioned only as a reminder that this system are beam grillage. Okay, dia macam grill saja, jaring. Okay, which work in bending and torsion. Okay, bending and torsion. Okay, rather than axial. Axial daripada atas. Okay, bending and torsion from the sides. Okay, okay, daripada kiri dengan kanan ataupun sisi. Okay, depending on the direction assigned to the members, grids may be identified in 2 or 3 directions. Okay, grids in 2 directions are more rigid. Beams follow the direction of the principal stresses of the equivalent plates and are widely used. Utilization is restricted about 10 meter of span. Okay, macam yang ni, for square, 2 direction. Okay, 2 direction kita nampak satu menegak, satu melintang. Alright, okay. The second one is diagonal, 2 direction juga, tapi dia different manner, which is diagonally. Okay, dia bersilang. Okay, satu silang ke kanan, satu silang ke kiri. Okay, but they have different qualities or different structural strength in between these two. Macam ni, it may be subjected to some deformities. Okay, dia akan mungkin lah, dia akan sway macam sengit sikit. If force is exerted in either of the sides. Okay, kalau macam ni, it can resist some amount of the loading because it halves, dia bahagi dua dia punya distribution of the loads. So this is more kukuh than the square 2 direction tadi. Okay, 3 direction is even more stable. Okay, because it can resist the forces in any directions. Cuma dia tak boleh daripada axial lah, daripada atas dia tak boleh. Okay, for bending dengan torsion, it has the highest strength compared between the two earlier tadi. Okay, because this one, bila kita subjected to this force daripada bawah, you can see that the load distribution happens and it halves. Dia akan distribute, bahagi dua, the loading of these forces. Okay, it can stabilize. And another one, okay, bila the force is acted on the sides, okay, it will be subjected to the halving of the members tadi, kiri dengan kanan, and yang ini, tunjang dia memegang the other ends, the both ends of the grillage tadi. So that's where it can achieve stability in terms of the shape tadi, okay, and the structural stability. Okay, right. Okay, now we come to the double layer grid. Okay, macam tadi, dia satu je, dia sekeping saja. Okay, macam ni dia ada dua. Okay, satu dekat atas, satu dekat bawah, and it is connected by the bracings. Okay, so bracing ni pun dia akan provide stability to the structure. Okay, macam ni dia pakai triangulated ataupun triangular module of the space troughs. Okay, you boleh nampak the classification. This is upper layer. Okay, the bracing layer yang the dotted one, and the bottom layer dekat bawah sekali. Okay, this is on the plan punya view. Okay, on 3-dimensional ataupun axonometric punya view, this one. So you boleh nampak the top one, okay, and then the bracing, and then it is joined to the bottom layer. This, the interconnected ataupun interlink is the bracing. Okay. Okay, lattice grids is where always the top and bottom chords in the same vertical plane. Okay, all right. Spatial grids made up of triangular base, pyramids, square or hexagonal. There are a few patterns, and different shapes carry different characteristics on the structural strength. Okay, 2 kinds may be identified. One is where the layer geometrics are identical through displays of set grids, and the other layer geometric are different. Okay, differential grids. And these systems are suitable for spans up to 100 meter. Okay. For greater spans, it's necessary to incorporate triangular layer, a triple layer grids to avoid long members otherwise necessary with the increased depth. Okay. Alright. So, apa yang dia cakap member panjang-panjang ni is, okay, each of the modules consists of the identical members ataupun the same modules, okay, that are arranged together and connected together by the nodes. Okay. And ni rasanya I dah cakap sikit tadi, which is the layering of the grids tadi provides extra stability with each of the layers. Okay, usually we go for double or triple if needed. Tapi 4 or 5 is not very considered because yang tu dia dah affect the depth, okay, thickness of the truss. It might be not economical ataupun not workable, especially when you have too many apa nama ni meshing ataupun network of the nodes that connected. Okay. For example, kalau maintenance, when you have too many members ataupun too many layers of the mesh, susah untuk orang carry out the works of the maintenance. Okay, sebab dia macam berselirat kan. When you have too many layers, okay, that are the things that would happen. Okay, the size of the constituent modules depends on the several factors, principally the span, the load, cladding system, type of node, transportation, and erection facilities. All right. Okay. Okay, for span between 30 to 40, length members is about 1.5 to 3.5 are acceptable. Okay, right? So member length tadi macam satu lah, macam satu ni. Okay, 3 meter ataupun 1.5, between 1.5 to 3 meters dah cukup. Consider acceptable. Okay, alright. The advantage of the double layer grids are numerous. Okay, there are three-dimensional structures which can withstand loads from any direction. Okay, because it is in three dimension, so it can resist the torsion, the bending, the axial loads, many kinds and many direction. Okay, they are hyperstatic, okay, which is very stable, and buckling of some compression members does not cause the whole to collapse, as been demonstrated by mathematical models and experiment. Okay, the stability ataupun the strength of the uh, space frame structure double layer tadi is proven by the mathematical calculation and models, okay, experiment. Their rigidity minimizes deflection. So of course, when you have space truss macam tadi, it can resist the forces from many direction. So it can, that way it can minimize the deflection. Okay, they have a very good fire resistance, but still this is subjected to the material that we use, because when you have steel or metal that is not treated, it is still susceptible to the fire damage. All right. Okay, ataupun some of the metal needs to be coated before it can resist fire. Okay, their composition allows factory free prefabrication in modular elements which are easily transported. Fabrication precision ensures ease of assembly and erection. Okay, they allow a wide choice of support position owing to modular construction. Okay, the space between the two layers may be used to install electricity, electrical, and thermal piping. Okay, yes, macam I dah cakap tadi sikit, which is when you have space truss, okay, it provides some of the empty ataupun hollow spaces. This is where we can use as the place we can house the building services, your electrical, your wiring, your trunking, thermal piping. All right. Okay, installation is carried out by bolting. Okay, which is kita assemble satu-satu by bolting. Okay, and may be done well whatever the atmospheric condition. Okay, they provide indisputable aesthetic qualities because bila kita tengok space frame, it has some modularity and it has some intricacy. Okay, very intricate punya structure. Okay, so that adds to the aesthetic qualities of the building. Okay, from an economic point of view, it is important to have minimum number of nodes. Okay, it is therefore necessary to compromise between these criteria and those determined by the choice of the module sizes. Okay, sorry. Okay, it's best to have minimum number of nodes because when you have nodes, you have more points of the loading. All right. So to reduce the number of loadings, okay, it's best to reduce the number of nodes. All right. Okay. It is also the number of nodes ni dia depends on the module size. The smaller module size that you are using, and then you have more nodes. The bigger module size that you use, the less nodes that uh, incorporated in this space frame. Cuma when you have another one, which is members, members also subjected to the failures. So you have to balance out the number of nodes and the number of members so that either one of these is not apa nama ni, is not subjected to excessive amount of loads, because the key of designing the structure is to distribute the loads evenly. Okay, right? Okay, sebelum I pergi cylindrical volts, any questions on this? Jadi lebih kepada recap lah pada yang the preliminary of the uh, subchapter tadi. Okay. Okay, tak ada questions. Okay, so we move on to now one. The next one, which is cylindrical vaults. Okay, in the history of construction, cylindrical vaults appear as an evolution of arches. Okay, macam you tengok. Okay, arches is this one. Okay, when we have cylindrical vaults, it's basically transforming the arches into 3D. Okay, which is the repeat. Okay, macam tadi space truss, dia planar 2D, bila dia susun uh, with some alignments, it become 3D. Sama juga for the cylindrical vaults, daripada simple arch, dia repeat banyak kali in a one direction, it becomes cylindrical vaults. Okay, right? The use of metal has enabled construction to be carried out with the factory prefabricated elements which may be assembled on the site. Okay, again, the use of metal allow the apa nama ni, the metals ataupun the construction members to be manufactured in factory, okay, before it is transported and constructed and joint assembled at the site. Okay, the first example to recall is the Crystal Palace, which was erected by Joseph Paxton for the Great Exhibition in 1851. Yang ni I think you guys dah belajar dekat Western architecture rasanya. Crystal Palace. Okay, right? This shape has proved to be suitable for roofs of halls, railway station, and sports facilities because these facilities ataupun buildings, they houses a large crowd and it requires longer span. Especially contohnya macam railway station, the size of the platform, okay, it needs to accommodate the trains. Okay, so that's why it needs to have a longer span. So cylindrical vaults is very suitable for this, especially railway station, dia punya building form is elongated. Okay, so that's where the cylindrical vaults comes in as the most suitable building form that can shape up the overall building punya form. Okay, right. Maximum efficiency may be obtained for shapes with rectangular surfaces and a length width ratio of between 1 and 2. Okay, 1:2 ratio. Okay, right. The optimum shape is in the region of 0.15 to 0.20 as pictured in figure 9. Okay, right. Okay, several layer geometries are possible. Okay, you can see there are many geometries that can be shaped from the cylindrical bolts. In practice, three-directional system offer the most advantages. They may usually be analyzed by assuming pin-jointed behavior for the nuts. This assumption does not hold, however, some system where bending rigidity must be taken into account. Example, for a vault consists of prefabricated elements rigidly joined by the high-strength bolts. Okay, you tengok kat sini. Okay, in practice, three-directional system are the most advantageous. Macam yang ni, A, this is two directional, okay? Satu ke sana, satu ke sini, okay? Three directional, when you have three direction, macam ni, dekat G ni, you can see one is running parallel, okay? Another one is perpendicular, and another one is diagonal. Okay, this has a better stable ataupun better resistance towards the force compared to the A punya example. Okay, so this one maybe for D, maybe dia nak have some openings to the cylindrical bolts too, so it empties some of the modular at the top. Okay, macam this one maybe juga dia eliminate the bracing so that it can allow some lighting. Okay, this one pun sama, tapi it allows some numbers of the bracing towards the center. Okay, depends on what kind of building that you are designing, how to allow some of the lighting towards the building. So these are the determinant factor for you to use which kind of frame system for the cylindrical bolts. Okay. Okay, the sensitivity of this system to asymmetrical action, in particular to wind, should not be underestimated. Such action can even bring about force reversal in the member, as which is an additional reason for choosing three-directional geometry in which the length of the elements are identical. Okay, right. Cylindrical bolts also not spared from resistance towards wind. Okay, they still have some risk of being blown away due to the huge ataupun intensity of the wind load that causes reversal loads to the structure. Okay, so that's why some of the reinforcement in this case, three-directional geometry helps to reinforce the structure so that it stabilizes and it can resist the wind load ataupun lateral load. Okay. In the same way, choice of support condition along the boundaries influences the force distribution. Okay. So dekat boundaries, you have the choice of the support condition macam mana, the connection ataupun the nodes. It also influences the force distribution. Macam mana the force is distributed. Okay. So economical spans for single layer walls are in the region of 20 meter. It can be lower, okay, but rarely go above 20 meter. Yang tu dia considered not economical dah, okay, and not that effective. Okay, spans may be increased by inserting diagonal elements. They can reach up to 60 meter for double layer system. Okay, tengok the increase between the 20 meter to the 60 meter. So you can see how double layer system, it can double, triple the strength ataupun the length of the span that is allowable for the structure, or in some cases or even more. Okay, depending on the modularity ataupun the choice of the material that used in the structure. Okay, appropriate weights for double layer system may vary between 0.13 and 0.25 kilonewton per meter square, depending on the intended shape, support condition, and on the geometry of the sheets. Okay, for a uniform load between 0.75 and 1.50 kilonewton per meter square. Okay. Okay, another one is domes. Okay, tadi kita dah go through apa tadi first? Ingat tak? single layer, okay, and then single layer ataupun double layer, and then cylindrical votes, and now domes. Okay, these are the examples of the space truss. Okay, okay. Sebelum I go dome, any questions on the cylindrical vaults? Cylindrical vaults. Ni peminat Taylor Swift adalah suka sangat ni, vaults, from the vaults lah, apa-apa lah kan. Selingan je. Okay. Alright, domes. Okay, tak ada question. So kita go to terus kepada domes. Okay, domes constitute one of the most ancient forms of the construction. So dome ni memang orang dah develop lama dah. Okay, alright. However, big or small their size, the outline of the two-dimensional support is normally circular on the plan. Okay, jaranglah kita ada domes yang um, apa nama ni, dia rectangular base ataupun apa lagi, square base, jarang. Usually when we are referring to domes, they're most likely to have circular punya plan. Okay. Skeletal dome structures can be classified into several categories depending on the orientation and position of the principal members. Okay, how we position the members determines what kind of domes that we are using. For example, macam rib dome, it go across the diameter of the structure of the dome. Okay, it go across. Okay, macam tu, very simple. Dia tak ada horizontal punya members except for the footprint of the dome. Okay, and then there's another one, Schwedel dome. Okay, it has a few directions. Okay, it's not it's not one direction ataupun two directional. It has more. So that creates the stability of the dome. Okay, and then another one is three-way grid domes. You can see the domes are having three dimension. Satu yang macam vertically, satu at the diagonal on the left, and another one is diagonally to the right. Okay, so that also provides stability to this kind of dome. And another one is lamella dome. Okay, this is determined by the placement of the curve arches that is aligned with the form of the domes. Okay, all right. So the domes are of special interest to architects and engineers because they provide the maximum enclosed volume for minimum surface area. Macam mana maximum enclosed volume for minimum surface area? Kalau you tengok, okay, this one. Whenever we have domes, we can enclose a very large area underneath. Okay, that's why domes usually we use in the public ataupun public service building, okay, bangunan kerajaan, macam even mosque, where we need a large span. At the same time, it can cover a maximum enclosed volume for the space underneath, but at the same time, they have minimum surface area, which is ni, the perimeter of the dome. That's where it rested on the structure. Okay, dia tak macam apa nama ni, certain roof where altogether the shape of the roof to contributes to the weight. Okay, and it has surface area that the structure has to hold on to. Okay, macam dome, it only requires a very minimum surface area. Okay, especially when we are using a very thin materials. Okay. In the last 25 years, construction with steel section has largely replaced reinforced concrete. Reinforced concrete. So concrete was before we developed steel section, steel construction. Okay. The first two example concern single and double layer system. This system permits spans of about 40 meter and more than 100 meter respectively. Okay, right? So kalau you guna single layer dome, it can go for span of up to 40 meter. Macam tadi, it's a 20 kalau cylindrical. Okay, the double curvature of the dome allows increased span that is allowable. Okay, all right. and it allows a span of 100 meter when we go for the double layer. So you can see the increase from 40 meter to 100 meter, okay, by increasing the layer of the system. Okay, some double layer solution have encouraged record span of more than 200 meter. Okay, this is depends on the shape. Nanti I akan tunjukkan how the different shapes is affecting the span of the domes. Okay. Okay, the accurate analysis of dome has only been possible with the introduction of the computers, which has allowed some accurate study of the elastic behavior. Okay, elastic behavior tu macam mana? Okay, elastic behavior is the ability of the shape ataupun structure to retain ataupun to return back to its original structure when the forces are removed. Okay, for example, macam you ada bola. Okay, ini part of the analogy that I can relate with the dome. Okay, macam bola. Okay, bila you tekan, setengah bola dia akan bounce back. So that has higher elasticity behavior. Okay, kalau bola yang kita tekan tapi dia dah kimik, so it has less elasticity. Okay, so that's how we define ataupun kita can gauge the different elasticity of the different shape ataupun different forms. Okay, alright. So it is important to note that the large span single dome subjected to asymmetrical actions can experience global instability effect. So macam ni, single layer dome macam ni, bila satu force acting at the one side of the dome, it has higher tendency to deform. Okay, okay, dia akan jadi number dua ni. Okay, dia akan kemik. Alright. Ataupun in some extreme cases, when the force is resisted by the other side, it can become ni, yang the second one ni. Okay, alright. So that's where the use of the domes um, being chosen as because it has some elasticity characteristic. Okay, but the elasticity of the domes susah. It's very complicated to be calculated when we are using conventional method ataupun manual ways of calculation. But with advancement of technology, when we have computer software, so the elasticity of the domes can be determined. Okay, because one of the reason because dome ni is not a single curvature macam cylindrical vault study. Cylindrical vault study, it has some curvature that is consistent, so the strength ataupun the elasticity can be easily determined. Macam dome, it has double curvature, so memang susah sikit untuk calculate the elasticity. Okay. All right. Next. Okay. From the physical point of the view, it is important to stress the difference in behavior of the domes with respect to the cylindrical bolts. Okay, bolts. Okay, sorry, bolts. Bolts. The sensitivity to asymmetrical action and resistance to global buckling phenomena is strictly connected to the rigidity of this geometrical shape. So when you considering for a dome, it is very, very important for you to take note on the geometrical shape that you are trying to use as the base of the dome, because different geometry shape has different rigidity, so that affects the structural stability of the dome. Okay, for cylindrical vaults, their surface has a single curvature. Okay, single, so it can be developed on a plan. In contrast, domes having a double curvature resist any action by the virtue of the shape itself, which is circular. All right. Okay, definition of the geometric arrangement of elements, whether for a single or double layer construction, is a difficult problem to resolve. Okay, research is aimed at using fewer different lengths for the members. Okay, macam I cakap tadi, it is very important for us to fabricate the same length for each members. Otherwise, susah nak kira dia punya loading ataupun load distribution, and at the same time for costing. Susah untuk kena buat different custom for different length. Moreover, it is important to check that the polygons defined are as similar as possible in order to facilitate cladding. Okay. Fuller designed one of the first big development, the dome of the American Pavilion in Montreal, 1967, which is composed of two interconnected layers and constructed with welded tubular sections. The resulting structure is 5 over 8 of a total sphere with a diameter of 75 meter. Okay. Bila kita develop dome, it is very important for us to check the polygons that is defined as similar as possible. Sebab when you have a mixture of a triangular and then ada some parts hexagon, ada some parts pakai pentagon in your domes, susah untuk calculate the stability, especially we have different number of members for each. Macam triangular dia ada three members, and then pentagon dia ada 5 members, hexagon dia ada 5 members. So distribution of the loads tu jadi very complex and very complicated. So susah untuk kita calculate for each one. But when we have a very consistent ataupun uniform shape that we use, for example, we use only hexagon shape to shape up the overall shape of the dome. It will be much simpler or much easier to determine the structural qualities of the dome. Okay, because they are carry the same loading due to the same length of the members. Okay, it is more expected and easily determined. Okay, all right. Any questions before I move on to the next one? Okay, 08 ni ataupun I think lah maybe 08 memang akan ada some of you yang perhaps akan guna domes. So you akan notice that the consistency of the shape that you use in the dome is very important, especially when cladding your building. Okay, the joining, sebab you have to close your framing of the dome. You need to have finishing. So the finishing ataupun the joint member between the each polygons is very important. Okay, kadang-kadang bila kita guna different shapes of the polygons, there are tendency that the dome will leak. Sebab bila kita assemble, dome ni dia macam origami juga, dia punya module, where we have edges that mix. So when you have different number of the edges, different number of polygons, susah untuk kita determine where the points or the members would meet and the nodes punya position. So that makes the dome construction become difficult if you have different shapes modular for the domes. Okay, right? Any questions, Sadia? Okay, next. Okay, design of spatial truss system. Okay, by conceptual design, okay, it is important to define the geometry of the structure that I dah sebut sikit tadi, given that determining support position is an important factor in the strength and the rigidity of the system. Geometric design parameters are the overall shape, flat shape or assembly of small flat shapes, so-called polyhedric surfaces, curved surfaces, generally positive double curve surfaces. One of the curvatures may be equal to the zero. In example of the case of the cylindrical bolts. Okay, all right. For curved surfaces, a rise span ratio should be fixed to satisfy both mechanical and architectural criteria in order to avoid domes which are too shallow. Okay, shallow domes can be quite risky. Nanti I akan tunjuk. Geometry of the cladding supports is very important when considering the geometric design parameters. Okay, the layer of members, the number of layers, structural depth, span ratio influences the weight, strength, and the cost. Nanti ada graph that I can show you to you, the relationship between the span ratio and the weight, strength, and the cost. Frequency of the mesh, number of geometric elements for the given length. Okay, frequency of the mesh relates back to the geometry that you use. The smaller geometry that you have, the more frequency of the mesh that you will have. Okay, all right. Okay, the choices made directly influence the number of members converging on each node and the connecting angles between these members. These two parameters determine the feasibility of the nodes. Okay, I dah sebut in a simpler word tadi. Okay, too many elements meeting at the different angles and lack of repetition are hindrance to construction efficiency. Okay, all right. When you have too many nodes, you have many points of loading. Okay, so that becomes the apa nama ni the uh, limiting factor. Okay, in the structural stability and also construction efficiency. Okay, because when you have different angles, you have different methods of construction, so that also increases the efficiency of the construction. Okay, the choice of spacing of the grid should be related to the geometric connection, particularly on the connection of the two-dimensional sides of polyhedric surface. The choice of the support condition does not pose any specific problems, but it does affect the behavior. Okay, all right. So the choice of support condition biasanya dia tak berapa efek sangat, tapi it does have some different characteristic that also contribute to the stability profile of the dome. It should be noted that because of the low weight of these structures, the weight of the equipment supported by the structure should not be negligible. Similarly, actions resulting from the method of construction should be carefully examined. The effect of the concentrated action and of the partially distributed loads, which are greater when the total loading is not symmetrically distributed, should be examined. Okay, given in specific cases, dynamic action can be replaced by enhanced static action. Okay, from when you have domes, okay, you have different because of the low weight of the structure, kita kena consider the weight of the equipment, okay, supported by the structure. Okay, for example, okay, of different organization ataupun different connection of the domes may exert different loading on the building. Okay, especially when you have not symmetrically distributed loads, dia akan cause some of the point of the support to become uh, not affect the overall distribution of the loads. Okay, contoh, when you have another one point that is heavily supported and another one the not much on the weight, it will affect the stability of the dome ataupun the span of the building itself. Okay, right. Okay, design method, every project is undoubtedly an individual case. So different domes have different coverage, different dome has different span. So the every cases of the design method is very unique. Okay. Nevertheless, it is possible to establish sequential steps in the development of the design. Most importantly, it should be noted that for a shape to be covered in many predetermined ways, two distinct methods can be used to define the general surface. Either the overall space geometry is defined a priori, a geometric division must then be made. Okay, right. Sekejap sorry. I kena tak diri kejap. Sorry Wait for a while. Okay, sorry. Thank you for waiting. Okay, right, I sambung sikit tadi. Okay, either the overall shape geometry is defined as a priori, a geometric division must be made. A geodesic division for domes. Okay, geodesic ni can be defined by the domes that has a modularity of the same shape. Okay, contoh kalau pentagon, the whole the whole domes that use the pentagon, we call it by geodesic domes. Okay, all right. Or the generating module is laid before and multiplication of this module provides the final geometry. Okay. All right. Once the overall geometry has been established, the designer must decide on the number of layers. Okay, bila you dah establish the geometry. Okay, you nak guna hexagonal ke, you nak guna pentagon ke, the designer must decide on the number of layers. Whether you nak guna single layer ataupun double layer ataupun triple. Okay, this design depends basically on the free span. How many span, how many length that you are required for that design space. Okay, and also on the geometric distribution of the members in and between the layers. All right. The choice of the frequency of the mesh is very important for reason of resistance and cost, as well as for the aesthetic reasons. Okay, when you have a mesh of this bracing, no, bukan bracing, the frame structure, it provides some stability to resist the forces. And also for the cost, okay, for example, macam you nak eliminate in some ways, in some points, ataupun you nak using some of the members to of a reduced number, okay, you may the choice of the frequency mesh is determined by that, okay, as well as for aesthetic reasons. Maybe you rasa macam the more mesh is more beautiful, is more intricate, or you have less number of member ataupun less mesh, you can provide a more open atmosphere for the space. Okay, right. Choice of the geometry of the network members are directly influences behavior of the system. Okay, macam cakap tadi, the geometry really determines how the behavior of the system. For example, in the case of the double layer grids, an examination of different geometric arrangement has confirmed that the importance of adopting an arrangement where direction of the members in the two layers are set at 45 degree. This is the most optimum bracing angle ataupun the framing punya angle. Otherwise 60 may be okay, but depends on the thickness, okay, ataupun the distance between the double layering tadi. If possible, it is best to go for 45 because that's where the loads can be evenly distributed. Okay, it is therefore possible to examine the structural behavior under appropriate combination of actions. Choice of support conditions has a big influence on the distribution of internal forces and the size of the deflections. The possible use of multi-point supports is an important advantage of spatial stresses. Definition of the areas of the cross-section and the elements may lead to process of optimization suitable for the design model. All right. Okay. Any questions on this? Choice of support, choice of geometry, choice of frequency. So these are the few of the design consideration when you are going for a dome. Okay. Kalau tak ada, I proceed. Okay, initial sizing. Okay, it is possible to provide further information on the case of the double layer two-dimensional grids. The curve in the figure 13 illustrate the variation in weight suitable for different structural depths with the slenderness ratio for the 7 different geometries. Okay, so ada 7. Okay, grid height in the centimeter. Okay, macam ni. You can see this is the least height, yang paling shortest grid height. And this one is 275. Okay, kalau you tengok grid height ni, sekejap, ada tak? Macam this one, contohnya ni. Grid height between the ni So, tak adalah, tak ada gambar. Yang double layers tadi. Okay. For different consideration. Okay. Alright. So, double layers. When you have apa nama ni? When you have very short height of the double layers, it exert quite high punya weight. Okay. And when you have a balance between the ratio of the height and the span, you will get the the lightest ataupun the lightest weight for the dome. But inversely, when you have uh, higher grade of the double layer, it also poses high weights. Okay, alright. Kita imagine macam ni. Okay, 70 perhaps dia punya dome tu macam agak lepeh. Alright. So dia punya weight tu dia punya weight is from how the load ataupun gravitational punya forces. Okay. So it will transfer much of the load. Okay, tapi bila you have um, a balance ratio of between the span and the height of the dome, it helps to redistribute the load evenly. So that's why you can get a more stabilized and more well distributed of the weight of the dome. Tapi this one, when you have 275 punya ni, dia punya dome perhaps is a bit more lonjong ke atas. So, dia punya weight is from the sides that exerts through the gravity, so that adds to the weight of the dome itself. Okay, so that's how dia punya graph dia jadi macam ni. Okay, it has to be balanced for us to achieve the lightest structure that we can have for domes. Okay. All right, these are the few examples of the how bracing in the apa nama ni space frame. Okay, this is not necessarily cylindrical boats ataupun domes ataupun ni, tapi dia double layer. Okay, right, so you can see different arrangement of the chords. Okay, when you have this one, bottom chord dia dekat bawah. Okay, bracing dia is the one dekat tengah, and this one is the top chords. So bila dia join together, this is what you get. This is the section. So height ni yang determine the weight of the structure tadi. Alright. Okay. And then the second one, when you have top chords, okay, ke atas, bracing is in between the bottom chords. Yang ni dia ada two types of section. Bila you cut dekat area sini yang ada lubang-lubang ni, you will get this section dekat atas ni. Section yang belah atas ni. And then bila you potong dekat sini, okay, you will get this one. Okay, so there are some of the missing members of the mesh ataupun modular tadi. Okay, perhaps this one of the way to introduce lighting into the space underneath, ataupun dia nak reduce the weight. When you have less bracing, when you have less members, it also reduces the overall weight of the structure. Okay. Okay, this is another one. Okay, top chords dekat atas and then bracing dia yang kat tengah ni. Okay, and the bottom chords. Okay, yang ni kalau you nampak tadi, yang ni dia lebih kurang sama. Okay, this is square base, and then bracing dia macam tu. This one, square base and square base juga, tapi dia guna bracing at strategic point by grids. Okay, ada yang missing, ada yang tak, by alternate. But this one, dia boleh nampak, dia pakai top chords lain, bottom chords dia lain. So, they have different bracing. Okay, dia akan diagonal, dia akan ikut yang ni, that it can support the top chords. Okay, yang this one, okay, bottom chords dia macam tu, diagonally, top chords dia diagonally. Tapi bracing dia macam ni. Okay, so dia connects. Alright. Sorry. Okay, this is space frame. Okay, dia masuk space frame yang dia ada tunjuk sikit on the three dimensional. Okay, yang ni dia kena tunjuk by three dimensional sebab okay, from the plan nampak macam tiga-tiga ni sama. Dia diagonal from the side, bukan daripada atas. Daripada atas dia akan nampak square, daripada tepi you akan nampak dia as if bracing that is triangulated. Okay. So this one ada these are the basic profile, tapi we have yang ni dia nak tunjuk lebih kepada how the connection between the two still can have a different arrangement, the different methods of bracing, but at the same time linking to the same ataupun similar design of the bottom and the top chords. Okay, this one. Okay, top chords dengan the bottom chords dia sama, okay, tapi bracing dia diagonally. So this is more stable than this one because they have more members, especially reinforcing the overall structure by diagonal. Okay, all right. Okay, next. Okay, calculation were made for the case of the square outline with the peripheral supports under each node, assuming that a uniformly distributed load. In addition, the following data has been assumed. Okay, take a depth ataupun span ratio of 1 to 15 in relation to the free span where there is a working load of 1.5 kilonewton per meter square. Okay, right. Ini some of the example I wouldn't apa nama ni elaborate much on this. Okay, okay. Choice of the structural system. As soon as the overall shape of the structure is defined, it's necessary to choose the structural system. Okay, the wide variety of structural system is available which can fulfill the geometrical requirements of the design. However, they cannot all provide the load carrying capacity which is required to resist the most unfavorable design loading conditions. The sizing of this cross section of the members is the task of the designer. Okay, whereas the producer of the structural system must guarantee that the node member condition should be able to give full joint of full strength type. Only by means of appropriate qualification procedures can guarantee this be realized. Okay, macam tadi, bila kita develop this one, okay, maybe we can go for macam, okay, contoh kita nak pakai squarish punya grids. Okay, kita guna this one. Okay, maybe kita guna bottom chords yang macam ni. Dia ada diagonal and at the same time dia ada squarish. So the section this one, kita yang akan propose to the engineers ataupun structural team. Okay, and then they akan calculate how workable, the workability ataupun the stability of this structure. Okay, alright. Okay, qualification procedure. Okay, the qualification procedure should demonstrate the system for the space structure based on the basic node member joint, which is a full strength type. The demonstration can be done by calculation and by test. Okay, ada yang by calculation tu lebih kepada prediction using software, computer. Test memang the actual test being conducted on the structure itself. Okay, by real life, real time. Okay, on the one hand, it is possible to model the node member joint by the means of finite element techniques. However, it is not prudent to rely solely on this numerical result. Okay, numerical result lebih kepada dia punya estimation. Okay, right. On the other hand, only experimental evidence can fully demonstrate the actual behavior of the system. Kadang-kadang, when we simulate ataupun provide estimation on the simulation based on the structure. Contoh kita run simulation on the computer. Okay, computer cakap okay, structurally ni ukur. Okay, there are some few of the points that are very critical that needs to be reinforced. Okay. And then bila doing the actual test, oh rupanya critical point dekat tempat lain. Okay. So that's the um disadvantage of using computer ataupun software, because the actual material ataupun the actual characteristic is not uh, reflected in the simulation. Okay, kerana simulation ada dia punya dimension, ada dia punya types of the material that they have by preset. Tapi different material, different members ada different qualities. Okay, you're gonna grade apa punya steel, maybe different. Okay, so by that, the only experimental evidence can fully demonstrate the actual behavior of the system, whether it is workable ataupun tidak. For this reason, the qualification procedure should be based mainly on the laboratory test, the result validating on the calculation. Okay, so what preliminary, which is the simulation tadi, you can get estimation on how the behavior of the structure system. Tapi the actual test akan validate the result that we obtain from the analytical calculation. Okay, a suggested procedure could be based on the following phases: monoaxial test on the nodes, monoaxial test on the member to node connection, bending and shear test on full scale structure units, bending test monotonic and cyclic in the elastic range, including temperature effects, up to collapse on full scale prototypes. Okay, monoaxial test ni can be done on the node itself, okay, where the critical point. Monoaxial test on the member to node connection, maybe dia a little bit ketengah sikit, but to ensure that the member and the nodes are strategically and correctly placed, all right, to resist the force. Bending and shear test on full scale structural units. Okay, yang ni memang actual test lah. Okay, you have the stresses are applied to the actual structure units. The bending test, monotonic and cyclic, and elastic range. Monotonic and cyclics is also kita boleh define as a fatigue punya assessment ataupun fatigue test, where the amount of the loading are imposed on the structure repeatedly by cycle. So on a few cycle, how many times the loads are subjected to the structure, and bila masa yang eventually that the structural frame will fail. So dia boleh tahulah the quality ataupun the lifespan of the structure. Okay. Okay, analysis of space stress system. Okay, different analysis methods. Ada few apa nama ni? Few methods. Okay, the objective of the analysis stress system is to determine the values of the variables necessary for sizing purposes and for required to size their supports. The variable generally required may be compressive and tensile forces in the members in the system, node displacement, and values of the support reaction. The study has to be made for several cases of actions and combination of actions. The most unfavorable cases are used as the basis for the design. Okay. Okay, method of join. Okay, depending on the type of being examined, not necessarily determine all unknown quantities. Okay, ada kadang-kadang unknown quantities tu kita tak boleh nak determine. Okay, so it is still okay, but we need to ensure some of the important forces, okay, different qualities we need to determine so that we can conduct the method of analysis. Okay, so this is method of join, okay, applicable to two-dimensional system which are internally isostatic. Okay, isostatic apa maksud dia? Okay, the force and then the length are almost of the equal sides. Okay, right. Determine the forces in all members. They can be determined by analytical or graphical methods. Okay, yang ni two-dimensional schedule and the method of jointing. Okay, you boleh tengok how the direction of the forces. Okay, because bila kita develop this kind of graphical ataupun graph, okay, we need to understand the equilibrium of each of the members and the force that exert on it. Okay, macam ni. The direction from where the resultant force coming from where the direction of the axial force, benda-benda tu. Okay. So another one, okay, bila kita draft our method of join by graphical, it is kita bila kita susun them together, arrange, there are few forces that takes into consideration. Okay, you have equilibrium of node 1, okay, node 2, okay, and then ada node 3 and the 4. Okay, so this all four of this equilibrium must be illustrated in a unified diagram ataupun apa nama ni, ataupun visual, so that each of these member that are interconnected, we can identify the counter force of each of the forces. So this is where the overall graphical ataupun forces are in balance ataupun in equilibrium. Okay. Okay, method of section. In certain cases, this method can give direct access to internal forces in a limited number of members selected by the designer. It is used, for example, for preliminary design work in order to assess the maximum forces in a triangulated system. Okay. So method of section ni bila kita ada repeated modularity in between the structures. So kita boleh identify by the certain critical points. Macam ni, point upwards, okay, and then how the resistance on the structure and the loading that imposed on the structure. Okay, displacement method. This is the most general method. It is applicable to two-dimensional and spatial system, isostatic or hyperstatic. It gives values for all unknown quantities, internal forces, displacements, and reactions. Okay, design assumption. Okay, in addition to use of the principle which are common to all structures in respect to of actions and their combination, Eurocode allows a perfectly pin jointed model for a global analysis. Okay, ini assumption. Sebab otherwise kalau ada fix punya situation, it involves a whole different way to calculate. So most easiest ataupun the most optimum one is by assuming that the structures are all perfectly pin jointed. Furthermore, it is considered that all actions are applied at the system nodes. It is sufficient to assume linear elastic response. Okay. Calculation in elastoplastic range can be done by using simplified models of the members, okay, shown in figure 25. Okay. The results show that the reasonably stable response of compression elements after the ultimate load of a member is reached, okay, can be achieved, and the forces transferred to the adjacent members from that which has reached its ultimate resistance. Okay, alright. Figure 25. Alamak, dia tak ada lah. Dia terpotong, I think. Okay, alright. Okay, that's all for our class today. Our last class today. Okay. Any questions on this? Design assumption, okay, method of jointing, analysis, choice. Tapi theoretical lebih kepada yang belah-belah depan ni lah. How the design parameter, the types of the space truss, whether dome, cylindrical vaults ataupun single layer, double layer. Okay, alright. Okay. Okay, any questions? Tak ada. Okay. Okay, ni Afira. Thank you. Dekat chat stuff. 48. Okay. Okay, alright. So your structure exam is on I think balik. Okay, this structure design falls on 2nd February, which is on Friday. Lagi 2 minggu dia sekarang. Yeah, 2 minggu. Okay, so you have time to study on the calculation apa semua, because as informed by Madam Ruby, your your 653, the subject part 7 punya structure 60% calculation and 40% theory. So not much on what I have explained today, but some of the fundamental perhaps dia akan jadi sub questions lah for it. Even I pun tak tengok lagi the questions because the questions are prepared by lecturer from Perak. So I just follow and run the syllabus lah, especially dah hujung ni I cover for Madam Teguh Anis dengan Madam Shida. Okay, alright. Okay, I thought macam nak tak adalah gambar dengan grafin last class. Tak apalah kot. Okay, kadalah kot. Afira. I think sebab I think this should be my last class lah with you guys, sebab 08 I tak mengajar. I tak mengajar subjek, I tak mengajar studio, and I tak pernah dapat grafin as studio. Tapi I think okay kot, considering you guys punya apa nama limitation, and you guys should focus on the design. So I think tak apa kot. I can apa nama go for online lah instead, as suggested by your friend semalam. Okay, alright. Attendance ada kat sama kat siapa kalau boleh nak collect, nanti boleh bagilah ataupun put under my door. I can collect on behalf of Madam Teguh Anis. Siapa pegang? Alia ke? Siapa? Okay, whoever yang pegang nanti bolehlah letak dekat my room. Apa nama ni? Dekat aras 3 depan bilik I ada pokok dengan window door lift pattern kat situ. Okay, dah pukul 12. I think I managed to deliver on time, and I try my best to ni lah deliver, because structure memang is not really my forte, but I entrust with this subject. So insyaAllah next semester kalau ada siapa lagi yang repeat ke, na'udzubillah, I wish you all the best. Harap-harap tak ada fail lah. Tapi kalau ada yang failures, kita akan berjumpa lagi lah, sebab this will be my subject for next semester as well. Alright. Okay, so kalau tak ada apa, I wish you all the best for your design submission, for your exam, and then happy Friday Fridays lah for the guys. Okay. Alright. Okay, with that I'll end the session. Thank you for you guys, 48 students yang datang hari ni. Tadi 50 dengan. Alright. Okay. So tak ada apa, I will end the class. So thank you very much everyone. Okay, all the best for whatever that you venture lepas ni, your exam, your design. Okay, alright.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Sama. Alright.